This conference will now be recorded.
All right, so this is the plan, guys. During the last week, we have covered firstly what are Dockers. We have done an entire length of demo on how do you go and create a Docker image, and how do you use something known as a Docker file. And then, if you have a .NET application, how do you create that particular Docker image for a .NET application, and also store it into something known as an Azure Container Registry. So we created something known as a container registry. We stored the image in the container registry, and then we were telling that, okay, fine, you know what? If we can store the image in the container registry, we can then pull that particular image on top of, let's say, a web app or a virtual machine, and kind of run this out. Now, during this weekend, which is today, and we'll have a session tomorrow at 8 a.m. in the morning. So today and then 8 a.m. We and also I'll try to, let's say, take a session on Monday as well. If I get some time, I'll also go ahead and, let's say, put a slot on Monday or anytime in the next week. Or the aim here, or the target here, is to understand firstly what is Kubernetes. That's the terminology that I want to introduce you to. And then what is AKS, Azure Kubernetes Services, and how do you use Kubernetes? And even before I address the question called how do you use Kubernetes, I'll address a very important question on why do you need Kubernetes? I mean, why do you need it, and how do you really use it, and how exactly can Azure really help you? And finally, how can you integrate something like a DevOps practice out here? So all these session would take me around about 5 hours or so. 4 or 5 hours is what Kubernetes is what will take me. So I'll try to make sure that we complete it or we finish it by latest by the Tuesday. Which is, let's say, today we have a session. Tomorrow we will have one. Monday or Tuesday, I'll go ahead and take a session out there as such, so that we can cover this. And of course, yes, as I promised, we'll also do, let's say, some demonstration sessions on administration part. There are a few things like backup policies and all these things that I wanted to cover, which I'll take it in the next weekend out here. So that's the idea that I do have. So before I move forward, did anyone hear this terminology called Kubernetes before? And why exactly do you need a Kubernetes? What exactly for do you need a Kubernetes out here? Did anyone hear this term?
Yes, this is for container management.
This is for container management. Okay, good point. For container management,
Yeah, kind of an orchestration, automation,
kind of
clustering,
orchestration, clustering. Okay, orchestration, clustering.
automation,
Okay, automation. Yes,
of course, part of
automation.
cluster.
Mhm. Automation. So I'm just writing down all the points so that we can understand what exactly it is, and even people who do not know what Kubernetes is can also really understand that. But can you little bit elaborate on what do you mean by orchestration? What is this terminology called orchestration out here?
Make the process in serial order,
Mm-hmm. Okay, to make a
and
process in serial order. Okay. Mm-hmm.
and whenever there's something we want to build, simply we
Mm-hmm.
can click on that one script that will create the entire the requirement.
Right, but what requirement do we have? When you say
Uh,
requirement, what exactly it is?
like in a load
Mm-hmm.
balancing for creating in a clusters,
Okay. Okay.
scalability.
Okay. Right, those are, let's say, the services and also the properties of Kubernetes. But specifically on a very ground level, we'll try to understand what do you mean by orchestration, and why do you even need Kubernetes out here? No, why does Kubernetes even come into picture? And what do you mean by this terminology called orchestration? I'll start from there. So before I go into Kubernetes, again, just as a recap and just for benefit of everyone, when you want to create a Docker image, you firstly start with a Docker file. So you write a Docker file. So we'll start here. You start with something known as a Docker file, and based on this particular Docker file, what are you going to do is that you're going to go ahead and, let's say, issue a command called docker build -t and whatever is the name of the image, and space, we go ahead and give a dot out here. So we just go ahead and say, okay, fine, docker build, and then the name of this particular image hyphen dot. This will go ahead and give you a Docker image. And again, all these process something that I did earlier with DevOps also. So I just put the Docker file, then build it out. Everything with DevOps. I create a Docker image. After that, we just go ahead and store this particular Docker image into something known as a container registry. So I take a container registry and I store this particular Docker image in this particular container registry out here. And once I store this particular image in a container registry, I now need to search for a platform on which I can run this image on, or I can run this container on. So that's where I said, okay, fine. You know what? You can use an Azure Web App. This is what we did whole week last, where I was telling you that this is what we need to do, and this is how we need to, let's say, go ahead and deploy your container on, let's say, something like an Azure Web App out here. So finally, after doing all these things, what is happening is that your container is now running on top of a platform which is called as a web app. You can have one container, multiple containers, so on, so on, so forth. Now, the issue with this particular platform is that yes, this is good, but it doesn't understand how to manage the containers. When I say it doesn't understand how to manage the containers, the point here is that what if this container dies because of some process issue, because of some reason, the container or the, let's say, the code inside the container is probably not running, or the infrastructure on which this is running, this is not properly running, something like that. What if the container goes down? Meaning the container is no longer available. So I, as a user who's interacting with your application, will not be able to see your home page. Very simple. Or will not be able to see that particular, or will not be able to see a particular page, or I won't be able to do a particular functionality. Very simple. Which means that there is a downtime in my business, and there is, of course, loss for my business and all these things. Which means even if I deploy my containers directly on a virtual machine also, if I deploy it on a virtual machine, I can do that. I can simply create an Ubuntu virtual machine just like we did. I can pull down the image from my ACR, then create containers on top of it, run on top of it, expose the port and all that stuff. Again, even this platform, right, which is a virtual machine platform, it's not a pure container it's not a pure container management platform. When I say it's not a pure container management platform, what do I exactly mean is that, again, simple. If your container goes down, I, as a user, backend user, I need to log into that particular virtual machine. I need to run commands like docker run, understand why the container has gone down, then get the container up back again, so on and so forth. So all these platforms are not intelligent enough. I mean, if you put a code on them, yes, they are intelligent enough. They can go ahead and, let's say, help you scale the code out, scale in the code. A lot of things out here, right? This is something it can do. But when it comes to containers, it doesn't understand how to handle the containers. It doesn't understand how to orchestrate the containers. And this is where I'm using the term called orchestration. When I mean orchestration, how do you just handle the containers in a very, very, very simple English? How do you handle the containers? How can I get, or how can I, let's say, create a new container if one container is going down? How can I scale my container up? How can I scale my container in? All these things come under a broader area called orchestration. Here, orchestration nothing means handling or orchestrating the containers to make sure that the containers are live, your application is up and running all the time. And again, there are multiple container orchestration tools that are available in the market. Like you have a tool called Doc, sorry, Docker Swarm. You have a tool called Docker Swarm, which can orchestrate the containers. Not so popular, reason being it doesn't provide a good auto scale and all that stuff. And then comes your Kubernetes. Then you have something known as a Kubernetes out here, a product by Google, a product which is, let's say, designed, and it is now being maintained by a different organization, but it is developed, or this particular product called Kubernetes is developed by Google. Now Google says, okay, fine, you know what, since Dockers are becoming very popular, people are now facing issues how to handle their containers. So let me go ahead and create a software called Kubernetes, and you have a very good documentation around it too, called kubernetes.io. Go here at kubernetes.io. Again, you have, you know, a lot of things like learn Kubernetes basics, what is a cluster, what is a pod, multiple things which we will see about, which we'll see of course. But on a very basic level, right? When Google says that, okay, fine, you know what, I'm giving you a software called Kubernetes, and this particular software of Kubernetes is something that you can install on a host. Like for example, I get in a virtual machine here, and I say, okay, fine, you know what, I want to get this software called Kubernetes. I can download this from, let's say, kubernetes.io. I can go ahead and, let's say, you have different versions of Kubernetes, download this out. And when I download it onto a virtual machine, I get a package of softwares. It's just not one thing out here. I get a package. Very importantly, when you go ahead and install Kubernetes, Kubernetes, without telling to you, will go ahead and install Docker inside it. Reason being, Kubernetes is handling Docker images. Kubernetes is handling Docker containers. So Kubernetes is nothing but an addition on top of Docker. You can simply go ahead, run your containers the way they are. It will still work, but there is issue with availability. There is a lot of issue with availability out here. So Kubernetes is nothing but an extension to Dockers. So you have a Docker. I'm extending the Docker right now, and I'm now telling when you install Kubernetes, it install Docker first. Then you have something called as an API server, application programming interface server API. Very simple. Whatever commands you give to Kubernetes, it will be listened by Kubernetes, or it will be accepted by the API server of the Kubernetes, which is like the heart of Kubernetes out here. So it'll take your commands, it'll tell, okay, fine, you know what, you need containers, or you want to me, or you want me to handle the containers. Okay, let me go ahead and, let's say, do that for you. So API server is the endpoint that will listen to you, or is that particular, let's say, mediator in the entire thing, who will listen to you as an administrator. I'm not talking about an end user. This is you as a backend user out here, who can go and issue multiple commands out here, run your containers and so on and so forth out here as such. So you have the Docker runtime, you have the API server, and then there are something called as controller and scheduler, two important components which act as a brain of Kubernetes. So this API server is the heart of Kubernetes. Controller and scheduler together, they give you, or they form the brain of Kubernetes out here. Brain. Telling that, okay, fine, they have multiple logics that are embedded within them, which will continuously go ahead and monitor, let's say, your containers, and it will understand how your containers are really performing. Is your container healthy, or is there any issue with your container, or what exactly is happening with your container, and so on and so forth out here as such. This set of softwares, right? These are good. They will handle containers, but you cannot run the container on the same server or on the same host where you have all these things installed, controller, I mean the API server, the Docker, and all that stuff, right? So what you do is that normally what we do is that we create one more server or one more platform, whatever it is, and install another set of softwares on this particular platform or this particular machine, right? So here again, we would go ahead and install Docker. we install something known as a kubelet agent. We call it as a kubelet, and we connect the kubelet with the API server. And you can have multiple machines like this, which is having that particular kubelet software. So let me minimize this a little. You can have multiple machines like this, same configuration, which can have, let's say, the kubelet installed, which can have the Docker installed, and can be connected to the main API server. So what the server does is, now the server tells, okay, fine, you know what? You can run containers on this particular, let's say, servers, like either this or this, multiple containers again. And I, who is an API server, using my connections with this particular kubelet agents, I'll talk to them regularly, understand how my containers are really running. If there is an issue, I'll go ahead, let's say, create new containers. If you want me to scale it up, me as in like the administrator, if you want me to scale it up, I'll go ahead and, let's say, simply go ahead, give you multiple copies of the container running on, let's say, multiple machines out here. So what what it does is that it now establishes a parent and a child relationship between these machines. You'll tell, okay, fine, these all machines are my child machines on which their containers are running. So I'll make sure that I handle these machines as well. And this machine, right, on which you install the API server, on which the API server is running, we call this as a master node. We call this as a node. So instead of calling it as a virtual machine, we are now calling this as a node. And these two machines on which you can run the containers, on which the kubelet agent is actually installed, we call this as a slave. It's a slave node. One master can have multiple. Again, my question, my let's say elaboration here is this: one master can have multiple nodes. It will definitely have more than one or more than one. That's the reason we call this entire setup rate as a cluster. Cluster is nothing but a group. Here, cluster is nothing but a group of machines which are helping you run your containers so that your application is never down. And it's very intelligent, guys. Kubernetes is very, very intelligent in handling how containers are running. It will go to any extent to go ahead and, let's say, make sure the container is available. It will also go ahead and create new virtual machines on its own if it feels there's a need. So we'll see how the configuration really works out and so on and so forth out here as such. So that's where Kubernetes as a concept comes into picture. A concept for container orchestration, telling that, okay, fine, don't worry if your containers are failing, I'll make sure, meaning Kubernetes will make sure to go ahead and create new containers for you. Or if the containers are sick, destroy the container, recreate something new for you. And always to make sure that your application is up and running out here as such. So this is what Kubernetes really gives you, or this is what Kubernetes really comes into picture, where Kubernetes really comes into picture out here. And that's the first question, is that why do we even need Kubernetes out here? And what exact components that you get within a Kubernetes when you create one out here as such. So yes, I'll take a quick pause to just take a couple of questions and then we can move forward. So yes, anyone, any questions, guys, that I can take here? Anyone, any questions?
Sir, all
Sorry.
these machines are Ubuntu machines. Sorry, sir.
Could
Yeah,
be,
Madhu, go ahead.
it could, yeah. Go ahead, Madhu, sorry.
All these machines are Ubuntu machines only, right, sir?
Could be, it can also be Windows machines. I mean, you
Oh,
do not need an Ubuntu machine. If specifically you have Windows containers and you want to run it on Windows machines, you can also go ahead and run this on a Windows machine as well. Shouldn't be a problem at all.
in Linux machines, we are using some commands. Same commands we can use on Windows machines as well, sir. No
Yes, you
issue.
can use the same commands, but for Kubernetes, right, the commands will be slightly different, which we'll talk about on how the commands really works out.
Okay, sir. Meaning, and in slave nodes, all the containers having the same application only. It's a different applications.
It is, I mean, normally how it happens is that all the applications are the same in slave nodes. So if you have container 1 running irctc.co.in, container 2, container 3, 4, 5 will also run irctc.co.in out here, and we exposed over a common public IP. That's the reason, because I need multiple container instances, so that if one container goes down, the other can come up, right? So that's how I am trying to make sure that my applications are highly available. So yes, we can have or we can have the same application running on multiple containers out here as such.
Okay, sir. Thank you.
Yes, anyone else, guys? Gopal, you had a
So,
question. Go ahead, please.
yeah,
Mhm.
how many these Docker missions is required for slave missions is required for clustering? Is one mission is also fine, or multiple is always
Yes,
it's more than two is
one
required?
machine is also fine. Even one machine, we call it as a cluster only, because when you say one, there is one master, one slave, right? So there are two
Yeah.
machines in total. That's the reason we call it as a cluster. But one or more than one machine is always suggested. Again, it depends upon what kind of an application that we are running. If it's an application that which needs, let's say,
SLA.
scalability and also high availability, then yes, we will go and create multiple slave machines out here and run our containers across those slave machines, so that in case something happens to one slave machine, the other slave machine will have I mean, the other slave machine is in place. It will help you, let's say, go ahead and get your content back again out there as such. So you
Okay.
can have multiple slave, but at least one slave you need to have.
Okay. And one master node can be shared in a different clusters, multiple clusters.
One master node can be shared across cluster. Usually we don't follow the practice of, or usually we don't suggest to go ahead and, let's say, share it with multiple clusters. You can do it in a traditional Kubernetes, you can, but it is
Okay.
not suggestible. It is not suggested to go ahead and do that, because there will be a lot of load on the master if you go ahead and do that out there as such.
Okay. Yeah. Thank you.
No worries. Anyone else, guys? Any more questions here?
Sir, how will come to know like a container is
Mhm.
failed or it is in downtime or it is having some issues or we are configuration we are doing any configuration of health proof kind of background?
Mhm. Again, in a traditional service like an app service or a virtual machine, right, it's very difficult to go ahead and, let's say, or you can use, let's say, something like monitoring using application insights. You can configure your own queries to go ahead and, let's say, check the health of the container. Again, that's where I'm telling that it's manually a little difficult to go ahead and orchestrate these containers, and that's the reason. So I was suggesting an alternative service like Kubernetes. So what Kubernetes does is that Kubernetes implements its own health probes. It has its own health probes. It has its own controllers. It has its own metrics, and depending upon multiple set of algorithms, it goes and understands whether your container is it healthy, or if it's not healthy, then yes, let me get it up back again without the human intervention. This is what I am trying to, let's say out here, is that without human intervention, without human intervention, Kubernetes is now doing the monitoring for you. It's going ahead and doing, let's say, the monitoring for you. And we'll also talk about that and how do you, let's say, or how does Kubernetes do the monitoring out here as such. Even that's something that we'll look at.
Okay, thank you.
Yes. Any more
And
questions,
one
guys?
one more thing,
Please.
can we implement these for database reports, other background process applications as well, not only for web applications?
Yes, you can also do databases and all these things. And if you want to go ahead and, let's say, use databases, that's where concepts like persistent volume claims, and all these things come into picture. But yes, in short, you can go ahead and implement it for databases also.
Okay. Yeah.
But, hi, Kiran. Thing is
Okay,
that
please.
the data
I'm
SQL.
sorry, your voice is breaking up. I'm sorry, Jayanti, your voice is breaking up. I'm not able to deeply hear you.
Okay, now I'm audible.
Better. Go, please.
Actually, I have the data I want to extract from the application. Can we do it on the SQL basis?
Can we do it in what? Sorry.
SQL.
Yes, you can do it on SQL out here. Yes, you can do that. again, I understand your question partly. A bit of, let's say, disturbance at your end, probably. So yes, I mean, if you want to extract the data, depends on where your data release. But yes, you can extract the data in very short. You can extract the data. Yes. Okay. But there is, see, guys, if you see this right, there is one issue with this, is that again, see, the configuration of a Kubernetes was not really easy, guys. It's too difficult, because the reason being, if you look at all these components, I have an API server, I have a Kubernetes, I'm talking about something called as a master node. Then I'm telling that, okay, fine, we need to create these two nodes, and we create kubelets, and we go ahead and, let's say, attach all these things together and make a cluster out here, and then finally run our, let's say, our containers out here as such, right? The entire process is usually very, very difficult in order to set up. It's very difficult actually to go ahead and, let's say, set up a Kubernetes cluster for which we have specifically a role called Kubernetes administration and all that stuff. It's a little difficult to go ahead and, let's say, use the vanilla flavor of Kubernetes. Just go ahead, create a virtual machine, and get everything up and running. It's not that easy. This is an IaaS offering of Kubernetes. And this is the infrastructure as a service offering of a Kubernetes service out here. But what happened is that cloud providers realized this, and they said, don't worry, you don't have to, let's say, go ahead, create all these things. Don't worry, just tell us what you want, how many slave nodes you want, and what kind of a configuration you want, what is the name of your cluster, all those things out here. Just give me those details. I, as a cloud provider, either being Azure or AWS or GCP, I will set up the entire thing and give it to you in less than 15 minutes. I'll set up the entire thing. Usually, to go ahead and, let's say, create a cluster from the scratch, it takes a lot of time. It takes a lot of time and also expertise in order to go ahead and, really do this. But you go to a cloud vendor and tell them that, what, I need this particular service, or I need this particular containers. Sorry, I need this particular nodes and all that stuff. They say yes, we have such a kind of service available with us. That's what we call it as a PaaS service, as a platform as a service out here. And they're now telling that, okay, fine, you know what? Don't have to worry about that. Multiple cloud providers, they offer multiple things. There's something called EKS, Elastic Kubernetes, sorry, Elastic Kubernetes service by a cloud vendor called AWS, Amazon Web Services. There's also called GKE, Google Kubernetes Engine by GCP. And what we are going to look at is called as a AKS, Azure Kubernetes Service, which is a platform as a service offering for Kubernetes out there, wherein you can go ahead and create not only all these components. You have one, two, three virtual machines. Not only these things, but multiple virtual machines as slaves. Not only these things, but also the controller, the scheduler, the API server, Docker, and everything clubbed together. And Microsoft will tell, okay, fine, you know what? I'll try and go ahead and give you, not I'll try, I'll go ahead and give you the cluster when you want it. I'll create all these things, keep everything ready, and give the cluster to you. And you can now start talking to the cluster. We'll see how do you talk to the cluster and all these things out here. It'll tell, okay, fine, this is how it is and all that stuff. So that's where I'm getting into, on how do I create something called as a Kubernetes service. And for that, I just go here in search, just type in Kubernetes. You have something called Kubernetes service. Again, I have a service running. This is something that I created a couple of hours ago. And once I say create, I have something called create a Kubernetes cluster. And if I click on this, it's telling what is the resource group that I need to use. You can give a new resource group name, something like this. It's now telling, okay, fine. What I mean, it's telling that yes, to create a cluster, you need the nodes of this particular cluster. You need nodes, which is nothing but virtual machines, right? So it's now telling me what kind of a configuration of the node you need. And It's telling I have multiple configurations out here, like standard, testing, optimized, batch processing, hardened access. What exactly do you need? And if you just say learn more, it just tell you what size of virtual machine that you're going to get as the backend process or as the backend nodes. So if you click on this one, it is telling DS2V2. If I just come down to the DS series, DS2V2, it's telling that your machines will have something like two virtual CPUs, 7 GB RAM, 14 something like this. This is the configuration that you get for both the master and the child nodes. Or if you want to go for something like testing, I'll give you a size called B4MS. Or if you want to go for cost optimized, again you have multiple things out here as such. For hardened access, meaning for applications that are running in a production based environment, it also goes ahead offers multiple things like private clustering and all these things out. To start with, you can go with the dev test and say apply, and it's now going to ask you what is the name of the cluster. Just given some name. I am giving a name called test cluster out here, and choose a region that you can go ahead and let's say create your applications under. Mine was always ECUS2, so I'm going ahead with the ECUS2 out here. Then it is telling me after creating it, I'm not only creating this particular infrastructure, right? I'm also going ahead and installing something called as the softwares. That is a product of Kubernetes out here. I'm installing all these softwares. Can you tell me what is the version of Kubernetes software that you need? Normally we go with the default, whatever is the default we go with, we are good with that. But if you are, if your development team is looking for one specific version of Kubernetes, you can also do that. You can also go ahead and let's say change the versions out here. For now you can put it as let's say default. And all the softwares, right, they are automatically updated or they are automatically upgraded with let's say I mean they're automatically upgraded using the help of the platform, meaning Microsoft goes ahead and also takes care of the update. You don't have to even come again and tell Microsoft that where are my updates and all that stuff. No, they'll take care of it as well. And now it's telling this is still now you're selecting the primary node, or I would say the master node. Then it's telling what is the node pool or the slave nodes pool, as in a machine, let's say a cluster of machines. And it's telling I can also give you an auto scaling, meaning depending upon the incoming load, depending upon the traffic, I can start with one simple machine. I can auto scale this out. I can add multiple machines depending upon the traffic. And it's telling, do you want the child node to also be, let's say, same, let's say, configuration, or do you want a different configuration? You can also change that. You can also choose that. For now, I'll say it's the same configuration. I'll say the scaling method right now is manual. I'll just go for one node. This is the child node that I'm selecting, and this is the master node. Now, all these things are the master node that I'm selecting out here. So I have a, a single node cluster. It's not a multiple node cluster. When I say single node, it's the master and the child node that I get out here. Then if I say next, someone had a question that, what, can I add a Windows agent or can I add Kubernetes in Windows? Yes, you can add Windows, but you need your own networking. We'll come to that particular concept. But you can change Kubernetes to go ahead and let's say run on Windows as well. Shouldn't be a problem. But for now, I'm taking the Linux and access, networking, all these things. I'm not really touching anything out here. Again, I'm allowing Kubernetes to go ahead and let's say create its own network, because when I'm talking about machines, right, these are virtual machines and they need IP addresses, and each and every container that is running on your virtual machine or on your node also needs to have an IP, also needs to have an address. So Kubernetes is telling, okay, fine, you know what? I will use something called KubeNet, KUBNet, KubeNet, nothing but Kubernetes network. It's telling I'll create my own network, not a problem. And as a part of the creation, I'll also go ahead and give you a load balancer, a standard Azure load balancer out here. We'll talk about why it's giving me a load balancer, how can I really use it. And next, there is something called integrations. you can directly integrate your Kubernetes cluster to a container registry, because when I say Kubernetes, it's nothing but it needs an image to go ahead and let's say convert it into a container, right? So you can point it to a container registry. For now, I'll say none. Advanced, I'll say tags, I'll say review and create. That's it. So the only tab that I'm really focusing upon is the basics tab and the integration tab, where you can go ahead and let's say give an ACR, and once it runs all the final validation, string validation is passed, I'll go ahead and create this out. And once you hit the create button, right, it will take around about 10 to 15 minutes in order to create this. This is something that I could tell you based out of my experience, because you have nodes, you have all the softwares that needs to be installed, a lot of things that Kubernetes is in the background is doing. It's also creating its own network, a lot of things that Kubernetes is actually doing. So it takes about 10 to 15 minutes, and that's the reason uh, to avoid the delay, right? I created the Kubernetes cluster in before. So the only thing that I changed is the name of the cluster. Instead of test cluster, I'm putting it as a demo cluster. That's it. The only thing that I'm doing is this. And now I have a cluster with just one node. And here I don't have any containers yet. So I'll remove the containers. Let me expand the screen slightly a little bit. So I don't have any containers and all these things out. So I remove those containers out here as such. So I have an API master server, and I have a kubelet node server. These two things is what I do have right now. And in order to create anything, or in order to manage Kubernetes, right, I will have to talk to this particular API server. So I'll have to tell this API server, you know what, I need a container to be running, or I need multiple containers to be running, and so on and so forth. And in order to do that, Kubernetes will allow you to connect with it. Kubernetes will allow you to connect with the API server and pass in your commands. But in order to connect with it, you need to know the language of Kubernetes, or you need to have the command line of Kubernetes called kubectl command line tool. We call it as kubectl, kubectl. Multiple people can call it in multiple ways. And this is like a CMD, which helps you go ahead and let's say talk to that particular Kubernetes in the language what Kubernetes really understand. And this needs to be installed. This kubectl needs to be installed for you to go ahead and let's say I'm sorry, for you to go ahead and let's say start talking to that particular Kubernetes cluster out there. And how do I install it? Again, in my machine, all these things are already installed, guys. So even if I go ahead and show you it in my machine, it'll not be so fruitful. That's the reason I just created a Windows 10 virtual machine, so that I can just show you the demonstration of how do you install this on your local machines. You don't have to create a VM like I'm doing. I'm creating a VM only because I want to show you a demo. So let's go there into that particular VM. I'll give the username and password. So it's nothing like a Windows 10 virtual, it's nothing but a Windows 10 virtual machine that I created. And in this particular machine, I'm installing a tool called kubectl. The reason I'm installing that tool is that I want to talk to my Kubernetes cluster and give it multiple commands in order to run this out. And that's the reason I'm doing this out. So it will take about 2 or 3 minutes in order to let's say go ahead and install. It's a very simple installation procedure, and I'll show you how to end-to-end install this out. So you do not have to worry about that. But any questions still here? Anyone? Any questions still here on how did we create the cluster and what do we get while we create the cluster and so on and so forth? Anyone? Any questions? Okay, let's come here.
Sir,
Go please.
sir, in one cluster, how many application we can host, sir?
In
Single or
one
multiple?
cluster, when you say applications, do you mean containers or do you mean actual
Yes,
applications?
yes. Actual applications, not containers. Like a
You can have
Docker, etc.
multiple. Yes, you can have multiple applications running the same and running inside the same Kubernetes out there. Shouldn't be a problem at all.
Okay, okay.
And
Okay, sir.
each and every application can be running on multiple containers again. So let's say that you have application 1, app 1 running on 10 different containers. App 2 has its own 10 different containers. Both of them can coexist in Kubernetes. Shouldn't be a problem at all. You don't have to create a new Kubernetes cluster for the same thing out here as such.
Okay, sir. Thank you.
Okay. So I am inside the virtual machine. Let me go there. So I'm inside the virtual machine. There are a couple of things that you need out here. Very firstly, you need something known as Azure CLI, guys. This is something that we installed as a part of, let's say, Terraforms. So when we did Terraforms, we installed something called CLI. So since this is a new machine, I don't have CLI. So I'll again show you how to install this out. So I'll say Azure CLI download, and I'll go to the Microsoft documentation, install the Azure CLI. Scroll down, installer update. I'll go ahead and install this out. So I'm now going and installing the CLI functionality out here. And I'll just go ahead and let's say do an installation. Sorry, I'll do the installation out here, and once installed, I'll start showing you all how to go ahead and let's say install the kubectl in order to talk to the Kubernetes, and we'll see how it really works out and what kind of commands you have in order to let's say are on the offer in order to let's say go ahead and talk to the cluster. This is what I'll do. So let's go ahead and install this out and see what we get out here as such. And we'll run a very simple container in Kubernetes and see how it really works out. What is it exactly called? Because there is a different terminology for a container that you call it in Kubernetes out there. So we'll see what is that particular terminology and see how this happens. So let's wait for a minute and let's say finish. I'll open up PowerShell. It sometimes, right, sometimes you might have to restart your machines after you install the Azure CLI. Sometimes your PowerShell may not recognize it. So az hyphen help, and looks like this is installed. It's able to understand that there's an AZ module. What I'll do is that there's a very simple one-line command to install Kubernetes. What is that? Is that I'll say AZ space AKS. So I'm saying AZ AKS, which is Azure Kubernetes Service, install hyphen CLI. Please go ahead install the command line interface for Azure Kubernetes Service. I'll say enter. It's now telling yes, I understand what you want. So I will go ahead. I'll download the entire kubectl, or I'll download the entire let's say Kubernetes out here from something called as googleapis.com, because this is a Google, or this is let's say a Google let's say endpoint that this is offering, right? So it's telling, okay, fine, I'll go ahead and download the entire kubectl that you requested for. This is the version that I'll go ahead and let's say download, which is 1.2.5.4, something like that. So it's going and downloading all these things, and it's telling I've downloaded something called as a kubectl.exe in your system, in this path of the system. And there's also something called as a kubectl login. There are two things that got installed. One, there is something called kubectl.exe. The other is the login. Now what I'm going to do is that I'll just go ahead and take these both. One second, let's just go ahead and open up notepad. So login, and then the exe file out here. So these two, I'll just copy this out. These are the two things that I've downloaded. Just like the Terraforms, I'll say edit system environment variables. I'll say open this out. I'll say environment variables, and there is something called use variables for a test user. I'll open this. I'll say new variable. I'll paste these two paths here, one after the other. First path, I'll say new. I'll copy the second path also. I'll paste them both. I'll say OK, and here I'll say path. I'll say new again. I'll paste the exe again. I'll paste the login. So I'm just going in, pasting these both things. One thing here, I'm pasting it in the variables for this particular user. Then I'm also pasting it under the system variables, and I'll say OK. So I'm setting this out as an environment variable. And one quick thing that you can do is just run a quick command called refresh env, refresh environment variables out here. It'll just go ahead and understand that, okay, fine, I want to refresh and all that stuff. Okay, refresh environment variables. Okay, refresh env environment, fine, not a problem. Let me go ahead and reopen my PowerShell. And now I'll go ahead and start seeing if Kubernetes is installed or not. And I'll say kubectl hyphen hyphen version to see whether it's installed or not. Again, it's now telling kubectl is not a recognized commandlet function. Very common issue. All you do is just go ahead, restart your computers. Once you install Kubernetes, your system should understand that Kubernetes is there. It has the environment variables. It has the environment variables out here, but still it might not recognize because let's say your system is not restarted a number of reasons out here such. So once you do it a restart, once you give your system a restart out here, right now I'm not restarting this out, but once you can restart this out and come down to your PowerShells, sorry, come down to the PowerShell and say kubectl hyphen hyphen version, something like that. Or if I say kubectl version or kubectl hyphen hyphen help, something like this. So it just do hyphen hyphen help, and this should give you, or this should tell you that, okay, fine, all these commands are actually installed on your system. It's telling yes, Kubernetes is now installed in your system. The kube command line tool is now installed in your system. Now you can go ahead and start working with Kubernetes. This is the let's say indication that you need to look for. And what I'm going to do is that all simple. I created a Kubernetes service. I want to now connect to this particular Kubernetes service. And there is this button called connect here. There is this button here called connect. If I click on this, it's telling these are the commands that you need to set, or these are the commands that you need to run. AZ account set and the subscription. Very first, very importantly, if you're not logged into Azure, just say AZ login. And once you do the AZ login, and once you go ahead and let's say log into the Azure portal, you can go ahead and run all these commands. So now it's telling sign in. I'll just go ahead and sign in here. And it's now telling yes, it's trying to sign in here. It'll take a minute or so to get signed in. And once this is done, I'll now go ahead and say AZ, AKS, credentials, my resource group, and etc. Or the first command, which is account set. I'll copy this out, paste this out. And once this is done, right, I will get the I will get the authentication for Kubernetes by running this command called AZ, AKS, credentials, the resource group name, and the name of that particular Kubernetes service. I'll copy this, I'll paste this out, and I'll say enter. So I'm now trying to get the context for Kubernetes. So I'm telling, okay, fine, I need something known as a Kubernetes configuration file so that I can talk to Kubernetes out here. And now I am inside my Kubernetes using the command line. So a couple of steps. One thing, you need to install the AKS CLI. How do you need to install this? And before you need to install this one, you need something known as the Azure CLI. After that, using one simple command called AZ, AKS install -CLI, I went ahead and I installed this out. And once this is done, I set up my environment variables, restart your system, restart once the system is restarted, then come back, log in using AZ login, and then account set, and then this very important command called AZ AKS get credentials, and the resource group name out here as such. This is what I did till here. Yes, any questions that I can take till here? Anyone, any questions that I can take till here? Anyone, any questions till what I have done till now? Yes, no, maybe. Are we good to move ahead?
Yeah, we can move.
Okay, so let's check this out. Now, the ultimate goal of Kubernetes is to go ahead and let's say run your container. Let's say you want to run an Nginx container. That's it. Let's say something like an Nginx container. But before running a container in Kubernetes, right? What we do is that we create a basic object of Kubernetes called as a pod. Pod pod. Pod. A pod is nothing but like you have a resource group in Azure, right, in which all your resources are sitting. A pod is a shell inside which the container will be running in. You directly cannot go ahead and create a container in Kubernetes. You'll need to create a pod on Kubernetes, at least one pod, and then run a container on top of it. Also, one very important thing that you have to understand here is that although you can have multiple, let's say, containers for one pod, meaning I can have n number of containers inside the same pod out here, but always the best practice is that please maintain one container per pod. It's like one pod, one container. So instead of telling it is a container directly, I am going ahead and telling that, okay, fine, I'm going ahead and creating a pod out here as such. This is what I'm doing out here right now. So I'm telling I want to see firstly if there are any pods that are running in my system, in my Kubernetes system. Are there any pods that are running? I can do it in two ways. One way, I can just scroll down into my Kubernetes service, and there is something called workload. Under workload, there's something called pods, and it shows that all these pods are running in the background. These are all maintained by the Kubernetes system itself. To let's say, get multiple matrices and all that stuff. Kubernetes is already running some pods out here. What I can do is that I don't want for all namespaces, and I'll just click here. I'll say I need what are the pods running for a default namespace. We'll talk about what a namespace really is. A default namespace is allocated to you, meaning you can go ahead and run your own pods here in this particular, let's say, environment. A namespace is nothing like an environment, like a dev environment or a QA environment, something like that, right? Here I said, okay, fine, there's a default namespace. And saying there is nothing here in the default namespace, and this is one of the ways to check whether there is any pods running in your system. Or you can go ahead, run a command called kubectl. So cube command line tool, kubectl out here, get space pods. So it's now telling there is no pods in the default namespace out here. So what I'll do is that I'll create a pod. And when I say pod, a pod has a container running inside, and a container needs an image source. So a pod is nothing but sorry, a pod is nothing but a container which is running inside, and a container is nothing but an image source out here. So what I'm going to do right now is that I'll just go ahead, run a simple command called kubectl run, and I'll just go ahead I'll just say space the name of the pod. I'll say first pod. I'm just telling, okay, fine, this is the name of the pod, hyphen hyphen the image of the pod. I'll say image is equal to nginx latest or nginx. I'll say enter. In a second, it's telling, you know what, a pod is created for you. And if I come here now, just do it a refresh. Now it's telling, you know what, you have a first pod inside which there is a container that is running. So there's a container with the name called first pod whose image source is called nginx. So I just issued one simple command called what, kubectl run. Again, all these commands I have saved it out. I'll also share the documentation link with you all. You don't have to scramble for all these commands out here. So I'll just go ahead and share this out. Not Dockers, but Kubernetes and files and commands. And for example, I just said get pod, RS, and all that stuff. We'll talk about that. But if you check this command out, creating a pod, setting Kubernetes run, the name of the pod, the image source. That's it. I have a pod now running. I can also check this pod from my command line. I can say kubectl get pods. Saying yes, you have a first pod that is running right now. And if I want to understand more information for this particular pod, you can say kubectl describe. What you want to describe is that I want to describe a pod forward slash whose name is first pod. So what it does is that it'll give you an entire JSON body, or it'll give you an entire body out here, not JSON, sorry, and it'll tell you what is the image source of the pod, where did I pull from the image, when did I start the pod, and what are all the events that happened while you were creating the pod. So it's telling, you know what, whenever you started the pod, it's telling, okay, fine, I assign this pod to something known as this particular machine name. See, there's something called a case agent pool, something like this entire thing, right? This is your node. So the pod is now running on top of a node, and it's telling, okay, fine, I've assigned this to a node. After that, it's running a Docker pull command internally. I am not giving any Docker pull. I'm not giving nothing. This is when it created a Docker pull command. After that, it successfully pulled this out. Then it said, okay, fine, I'm creating the pod. I'll start the pod. Kubernetes is now going ahead and doing all these events one after the other, just based out of one command, which is kubectl create a pod. Done. Pod got created, and you can use commands like kubectl get pods, or you can directly go ahead and physically inspect this out. But this is something that I wouldn't suggest coming to the portal and let's say inspecting it out. You can still do that, but command line is more powerful than that. You know, in the coming sessions we'll also see how command line can really help you out. You know, what can command line really do out here as such, and so on and so forth out here. Yes, any questions still here, guys? Any questions still here?
Hi Abhishek, good evening.
Good, please.
Actually, I have not related to this, but I have a
Okay.
few questions which I was asked during the interviews. So can
Okay.
I, or after the session?
You can go ahead. I'm pretty much done with the session. I just wanted to give an introduction to Kubernetes. I can continue the session again tomorrow in the morning from here. I just want to take 1 hour and make sure that everyone is, let's say, following what this is. You can go ahead now.
Okay. So I know that how to create a branch and set a policy on it. But
Mm-hmm.
somebody asked me like how to set policies on directly on CI/CD pipeline, not on branch. Is that possible?
No, it is not possible. You need, I mean, the only thing that you have is a branch policy. It is
Mhm.
not possible to set up a policy on a CI/CD pipeline directly.
Okay. How to create CI/CD pipeline by using Jenkins?
Again, Jenkins, we haven't covered it yet. We'll look at Jenkins. We have a demo for Jenkins, so we'll look at Jenkins so that will make it clear. Again, the thing here, guys, is that Jenkins is just an alternative to Azure DevOps. That is not the main area that we are focusing upon. It's just an alternative, but we have a lecture for Jenkins and Octopus to go ahead and cover up open source technology out here as such.
Jenkins and Octopus, right?
Yes, so we are doing
Secondly, they're
Octopus
asking
as
about
CD.
Ansible.
No, Ansible is not
Ansible,
covered
Puppet,
as
and Bamboo.
no, Ansible, Puppet, all these things are not a part of an Azure DevOps engineer's role. You don't need to know
Mhm,
that. So before applying for a role or before giving the interview, right, just check out
mhm.
what are the areas that they're really asking for. So Ansible, Puppet, Chef, Bamboo, you have multiple tools out here that we do not
Okay.
predominantly use use with Azure DevOps. So you can say that you probably don't know about that because you never basically, or you never had a requirement to go ahead and use that in your project. You can do that, not a problem at all.
Okay. Second, last second question: how to create SQL database by using PowerShell? Can we create this?
Yes, of course you can create that. Yes, we can do that. You can do that. So, how to create SQL
Okay.
database using PowerShell? Did you Google it out after they asked you the question?
No.
Why?
No, I,
Why
I
no?
went to PowerShell and there I saw that MySQL option was there to create it.
Just a second.
But
It is a SQL database PowerShell,
mm,
and
It's just like how you are going to create in a command
create a
prompt.
exactly new hyphen something. You're not going to do a new hyphen AZ SQL database. So if I say new hyphen AZ Azure
okay.
SQL and database,
So,
you have a whole list of commands also explaining you, giving you the examples on how do you do this. How do you go ahead and let's say do this out here as such.
okay, I got this. Okay, I got this.
Mhm.
Questions are over.
Okay.
I need some support for the interviews.
Okay.
Like I'm able to crack few of them. Like not able to go with 100%, but yes, I can say that up to around 50 to
Hmm.
55% I am able to crack it.
Okay.
Yes, so I don't know how to go with 60-70%.
Which requires a lot of mock interviews, Deepak. Again, see, I wanted to connect with you one let's say Sunday, but it was not possible. But after that, you
Yes,
said that
yes.
you'll be coming to Edmund and then sending me an email, which I never got. So, once you send me an
No,
email,
I
I'll set up
came.
some time. Mhm.
I came on last Sunday, last Saturday. I was in Hyderabad, so I came to know that you are on leave. So I don't want to disturb
Mhm.
you. Yes,
Not
I
a
was
problem.
waiting
You
for
can
this
go ahead
first
and
class.
no problem. You can go ahead and let's say send me across an email and make sure to set up some time for the same thing out there. And yes,
Yeah.
we
Can
can
I do
also
it
do.
right now?
You can go ahead and do it right now. Yes, I can try setting up some time during this week.
Sure, sure, we'll do that. And one more thing I want to know:
Hmm.
how is Hitachi?
As a
Hitachi
company,
was the yes,
yes,
yes.
it's a good company. It's a good company. It's a product based company. It's a good company.
I have done with it. No, salary negotiation is going on. He said that for the salary negotiation, HR will be calling. So what does that mean? I
Hmm.
have already cracked it, or I have to wait for some more day?
It means that you've
Friday
cracked
only
it.
I
Yeah, it means that you've cracked it. They just want to go ahead and discuss about the salary out there.
because Friday I had,
Hmm.
and I'm waiting for their update. Oh, sorry, Thursday I went with the interviews.
Okay, sure. Let's see. Let's wait for the update.
Yes. Once we'll connect, then I need some few more things to discuss with you and get an update on that, and and to crack more interviews.
Sure.
So I'll mail it.
Hmm. Sure.
Okay. Thank you.
Okay. Thank you. Anyone else, guys? Any more questions? So tomorrow we'll have a session at 8 a.m. in the morning, and we'll continue with this and understand what exactly are the commands and etc. Again, see, I can go right now and explain all those commands, but it'll be a little bit of bouncer if I do that right now. Reason being, you'll need good amount of time, and that's the exact reason why we are making sure to conduct these sessions on a weekend, because you need a lot of time to let's say really practice this out, really understand this out here right now. So we'll connect tomorrow morning. We'll discuss more on this, and we'll take some questions out there. Thanks, guys, and have a good evening ahead. Thank you.
Thank you.
Thank you.
Thank